Hello and welcome to section 3.3, increasing and decreasing functions. So now in this section what we're going to talk about is basically how we're going to determine whether a function is increasing or decreasing. And you should probably already know this, it's just maybe you haven't put it together, or maybe you have, that a decreasing function will have a negative slope. And an increasing function will have a positive slope. And so if it has no slope, has a zero slope, then it's a constant function in a horizontal line. So if we're going to determine that a function is increasing or decreasing, we're going to do this by looking at the slopes of the line. Well, then think about this. How are you going to find the slope of the line? Well, it's going to be derivative, and so we'll go through and look at how the derivatives are acting to find the slope and find whether the function is decreasing or increasing. So there's a test for increasing or decreasing functions, and that's what I was just talking about, that if I take the derivative of the function and I find out that it's negative, then we know the function is greater than 0. I said that backwards, sorry. If the function is greater than 0, it would be an increasing function, which means it has a positive slope. A negative slope will be a decreasing function, and a zero slope would be a positive function. So make sure you get these down. This is what we're going to be talking about in this section. So here's an example. It says we want to find out on which intervals this function is increasing and decreasing. Now you got to kind of think about this, because think about what we were doing in the past when we were finding extremas. When we were finding a graph that maybe did something like this, we found that there were zero slopes, a constant slope, at maximums and minimums. So if we are before that minimum, we are decreasing. After that minimum, we're increasing, and after that maximum, we're decreasing again. So if we had a graph that looked something like this, then we could see that if we have a decreasing slope and find the zero slope, then after that it's going to change and go to increasing. So we could kind of keep an eye on the slopes around the points where we have horizontal tangents, where our critical numbers are, so that we could figure out whether we're increasing and decreasing. So there's the hint on what we're going to be doing in this one. We're going to take the derivative of this function, find the places where the derivative is equal to 0, because that's where the slope is 0, a constant slope, and therefore we could look around that slope, and up to that point it should be either decreasing or increasing. And so that's how we're going to determine this. So if I go ahead and take the derivative of this function, which I'm just going to take the derivative, you've got it written up there, would be 3x squared, and then if I take the derivative here, I get 3x. So again, derivative equal to 0, we'll find our critical numbers, we'll find the places where we have horizontal tangents. So if I do that, I could factor out a like term of 3x, and I don't need that equal sign there, I don't know why I wrote it, 3x, and that leaves me with an x minus 1 when I would undistribute. So 3x times x would be 3x squared. 3x times negative 1 gives me negative 3x. And so now I have these 2 points. I have 3x equal to 0 and x minus 1 equal to 0, where my critical numbers appear. So x equals 0 is a critical number, and x equals 1. So critical numbers, very important. These are where we have horizontal tangents. And so if that's the case, then we need to check around these points to see what's going on. So if I was to check below this point, so we're going to have f of, we should say that f of 0 is equal to 0, and we know that f of 1 is equal to 0, f prime of 1. We know those slopes. So we're going to have to check around these guys. And I need to kind of move them down. We need to check around these guys to see what's happening at the derivative before and after this. So I'm going to check f prime of, say, negative 1. Seems like a decent number to plug in here. And I don't really care whether it's what the number actually is. I just need to know whether I'm going to get a positive or a negative number. So plugging in negative 1 here gives me a positive 3. Plugging in negative 1 here gives me a positive 3. So they're both positive combined together, means that that's going to be, so it was an increasing slope, increasing from negative infinity to 0. Because before, where horizontal tangent happened, we had a positive slope, so it's increasing. If I plug in a number between 0 and 1, say like a half, into my derivative, then I would say, okay, well, a half in here is going to give me 1/4, so that's 3/4. Over here, this is going to give me negative Oh, negative 3 halves, and so 3/4 is smaller than 3 halves, but we're subtracting them, so we end up with a negative slope, so we're decreasing between 0 and 1. And you'll notice that I'm using open intervals at 0 and at 1 because at those points at 0 and 1 they are horizontal tangents, so those numbers aren't included in my solution. And I always have to use an open interval around an infinity. So then I'm going to check a number bigger than 1, which would be something like 2, and plugging 2 into my derivative, I end up with, let's say, 12 here, minus 6, which is still a positive number. So again, we're increasing, and so increasing from 1 to positive infinity, because everything after that number should be positive. And so those are my intervals, and that's really what I was looking for. Find my intervals where I was increasing and decreasing. Well, what we just did here is what we call, well, these are our guidelines. So we're basically just what I just did here. On an open interval, we're finding out whether it's increasing. We're going to locate the critical numbers. That's what we did by taking the derivative. Critical numbers are f prime of x equal to 0. And that's what we do first. And then after that, we're going to figure out, we're going to test a value on each side of that interval. And so we're going to determine the sign. That's what we did, positive or negative, on either side. And then if it's increasing if it's positive, and so this goes back to the theorem that told us about increasing and decreasing functions. It was increasing if f prime of x was greater than 0, decreasing if f prime of x was less than 0. And so then we're going to use those to write our intervals. Now the only trick to this is that occasionally we may have a critical number, say like at this guy at 0, or somewhere over here, that it's always increasing, So you may get a positive here, a 0 at this point for the slope, and then a positive here. And so what we call these are strictly monotonic or monotonic functions. They can always be increasing or always decreasing. And so you got to be careful. The reason why we're telling you this is you got to be careful because sometimes when you get a critical number, like you find the slope is 0 here, you may think, oh, well, I'm increasing, so my automatic next turn is going to be decreasing. So that's going to be either a maximum. And so you can't jump to those conclusions is really what we're trying to tell you, is you can't jump to the conclusions that once you have a 0, that you're always going to have either a maximum or a minimum there. Because this guy is neither maximum or minimum. Because something like x cubed is strictly monotonic, and it always will increase. Or if I put negative x cubed, the graph would always decrease. So you got to be careful, so you still always have to check. And so then basically what we just did was we did the first derivative test. And the first derivative test is what I was doing was to find out whether the slope changes from positive to negative to find a maximum or a minimum. And so as you're doing this, you're just going to take the derivative like we did, set it equal to 0 to find the critical numbers, and then you'll determine whether you just like I did, plugging in values on either side for the derivative to find out whether the graph is increasing or decreasing. If there is not a sign change, it is not a relative maximum or minimum. So please get these down. We will talk more about this in class, and I'll give you a neat little way to set this up in class. And so make sure you get these down and ask your questions.